Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is OCR November 2024, Paper 2, Foundation Tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends because they might need a helping hand too. Okay, let's get into it. Question 1. Write down a multiple of 9 between 30 and 40. Okay, well if you think about the 9 times table, what's that then? Goes 9, 18, 27, 36, 45. So which ones are the ones between 30 and 40? It's that one, isn't it? It's 36. So it's going to be 36. And then part B says write down a factor of 100 between 11 and 30. So what are the factors of 100? Factor pairs of 100, 1 and 100. Nope, they won't do. 2 and 50. Nope. 3, no. 4, yep, 4 and 25. Well, 25 would work, wouldn't it? So, yeah, we could have 25. We could also have 20. 20 and 5 are factors. So that's also between 11 and 30. Incidentally, are there any more? 6, nope. 7, nope. 8, nope. 9, note 10. Yeah, 10 you can have. 10 and 10 is 100, isn't it? So yeah, either 20 or 25 would be the correct answers. Question 2, work out 7 plus negative 5. Well, adding a negative is the same as taking away. So that's the same thing as 7 subtract 5, isn't it? So if I take 5 away from 7, I'm left with 2. Part B says 26 times 6. So 26 times 6, what's that then? So 6 6s are 36. I'm going to write down 6 carry 3. 2 6s are 12 plus a 3 is 15, isn't it? So it's going to be 156. Part C says what's 1648 divided by 8? I'm going to try that using short division. So 8's into 1, 6, 4, 8. Well, 8's into 1 don't go, so I carry the 1 over. 8's into 16, that works, doesn't it? Goes in twice. Remainder 0. 8's into 4 don't go, so it's at 0, and then carry the 4 over. So 8's into 48. Well, that works. That's 6 times, isn't it? So the answer is going to be 206. Finally, I've got 4.78 plus 5.3. So addition with decimals. Need to align the decimal point, don't you? Okay, so I'm just going to pad out that 5.3 with an extra 0, so it's got the same number of digits as the one above it, and then we can just go ahead and add 8 plus 0 is 8, 7 plus 3 is 10, so that's 0, carry 1, and 1, 4, and 5 adds up to 10, so that's 0, carry 1, so that's 10.08. Question 3, the vertical line chart shows rainfall in millimetres in March and April. Write down the rainfall in March. Well, you can see March is this bar here, and it goes up to halfway between 30 and 40. So that's going to be 35 then, isn't it? Part B says, in May there was 55 millimeters of rainfall. Complete the vertical line chart for May. Okay, so May needs to go up as far as 55. So I'm just going to get a ruler out and draw my line from May. From May, going up from 0 up to 55. So that looks about right. And then finally work out the total rainfall for March, April and May. So we just drew a bar for May, which was 55. And we knew that March was 35. April is 70, isn't it? So add in those 3 up then. So 5, 0 and 5 adds up to 10. So that's 0, carry 1. And then 3, 10, 15, 16, isn't it, for those of us? So that adds up to 160 millimeters altogether. Question 4, here is a rectangle. Work out the area of the rectangle. Okay, well, area of a rectangle is just length times width. So I can see from my diagram that length is 6 and the width is 4. So subbing those into the equation, 6 times 4, that is equal to 24 then, isn't it? 24 square centimeters. Question 5, complete each statement. 35 kilograms is how many grams? Well, I know that 1 kilogram is 1,000 grams. So if I multiply that up by 35, that's going to be 35,000 grams then, isn't it? So 35,000. 203 milliliters is how many liters? So again, 1 liter is equal to 1,000 milliliters. So 203 milliliters is not quite a liter, is it? It's going to be a fraction of a liter. So that is going to be 0.203 litres, isn't it? Divide it through by 1,000. And then finally, 4 square centimetres is how many square millimetres? Now, just take care with this one because area is a little bit trickier if you've got like a square centimetre. So we know there are 10 millimetres in every centimetre. But if you think about area, it's length times width. So the length is going to be 10 millimeters and the width is going to be 10 millimeters. And that's going to be the same as 1 centimeter squared, isn't it? And 10 times 10 is 100. So there are 100 square millimeters in 1 square centimeter. Okay, so knowing that, then 4 square centimeters is going to be 400 square millimeters then. Okay, right, part B says a train travels 90 kilometers at an average speed of 40 kilometers per hour. Work out the time taken for the journey. Give your answer in hours and minutes. Okay, so this is a distance, speed, time question. So which one of those things have I been given? Normally they give you 2 and you need to find the third one. So here I've been given the distance. A train travels 90 kilometers. So that's my distance there, isn't it? That's 90. And I've been given average speed. So that's that one. So that's equal to 40 kilometers per hour. And I want to work out time. Don't know what time is. So covering up time on my triangle, it tells me what to do with the other 2. So time is distance divided by speed. So subbing in the values, I've got 90 divided by 40. Okay, so what's that then? So I can cancel those zeros. That's 9 divided by 4. 4's into 9, goes twice, remainder 1. So that's 2 1/4. So that's in hours, isn't it? So what's 2 1/4 hours in hours and minutes? Well, 2 hours is 2 hours. And 1/4 of an hour, how many minutes is that? If you think there are 60 minutes in an hour, then 1/4 of an hour is going to be 15 minutes, then, isn't it? 60 divided by 4. So 2 hours, 15 minutes. Question 6. There are 16 coins in a bag. There are 6 5p coins, 2 10p coins, 8 20p coins. The diagram shows a probability scale. It's going from 0 to 1. 1 coin is taken at random from the bag. Which arrow shows the probability that the coin has a value less than £1? Okay, well, 5p is less than £1, 10p is less than £1, 20p is less than £1. They're all less than £1, aren't they? So the probability that it's less than £1, well, that's all of the coins. It's all 16 coins, 16 out of 16, which is 1. So which letter matches 1? It's going to be F, isn't it? F matches 1 up there. So I'm going to write F down for that one. Okay. Is a 20p coin. So what's the probability of picking a 20p out? Well, how many 20p coins are there? There are 8 20p coins. So I'm going to do like 8 over a total of 16 coins. So 8/16, that's the same thing as 1/2, isn't it? So a half. So which letter is pointing at a half? Well, that's the letter E, isn't it? That's pointing at a half. Okay, so then that is going to be E. Then finally is a 50p coin. Well, there are exactly 0 50p coins, aren't they? Because they're all 20s, 10s and 5s. So that's going to be 0 out of 16. And what is the probability then of getting a 0? Well, that's that letter there then, isn't it? That's going to be A. Part B says more coins are added to the 16 coins already in the bag. 1 coin is taken at random from the bag. The probability that the coin being a 5, a 10 or a 20 coin are now all equal. Find the minimum number of coins that must be in the bag. Okay. Well, now I want to add as few coins as possible. So I need to top up the lower amount of coins so they're equal to the one I've got most of. So I've got 8 20p coins. So if I top up the 5p coins and the 10p coins, so I've got the same as the number of 20p coins, then I'll have the same number of each. And so the probability I pick one or the other is going to be the same. So what do I need to add on to my existing coins to get the same number of each? Well, I obviously don't need to add anything to the 20p coins because that's the most. But if I add on 2 5p coins, I'll go from 6 to 8. And if I add 6 10p coins, I'll go from 2 to 8. So that's all together, that's 2 plus 6. Then that is going to be 8 then, isn't it? So find the minimum number of coins that must be in the bag. Well, then in that case, it's going to be 16 plus the 8 I just added. That's 24 altogether. So 24 coins altogether. Question 7, part A. Work out 1/3 plus 2/7. So fraction addition. When we're adding fractions, we need to have the same denominator. And at the moment, they're different. I've got a 3 and I've got a 7, haven't I? So what I need to do is come up with a common denominator for both of these, a number that 3 and 7 both go into. So if you think about the 7 times table, 7, 14, 21. 21 is in the 3 times table and in the 7 times table. So I'm going to make the common denominator 21. Okay, so then what we're going to have to multiply 3 by to get 21, I'm going to have to multiply that by 7. So times in the top by 7 as well, I'm going to get 7 out of 21. So that's a third. And then 2/7 to get sevenths into 21. So we're going to have to multiply by 3. Multiplying the top by 3 as well, I'm going to get 6 over 21. Okay, so now I've got my denominators matching. I can go ahead and add the numerators. 7 plus 6. That is 13 over 21, isn't it? Because 7 plus 6 is 13 and the denominator stays the same. So it's going to be 13 over 21. Part B says 5/8 times 7/10. Give your answer in its simplest form. Well, I've got 5 over 8 times 7 over 10. Now, I could just go ahead and multiply top with top, bottom with bottom, and then cancel. But actually, it's easier to look for common factors before you multiply. Because dividing smaller numbers is easier and multiplying smaller numbers is easier. So if I have a look at what's on the top and what's on the bottom, I can see I've got a 5 on the top and a 10 on the bottom. Now these share a common denominator of 5. So dividing that one by 5, I'm going to get 1. And dividing that one by 5, I'm going to get 2. Are there any more common denominators top and bottom? No, I don't think so. 7 and 8 don't go into each other, do they? So that's it. So now that I've kind of simplified it down as much as I can, now I'm going to go ahead and multiply. 1 times 7 is 7, and 8 times 2, that's 16. Now, because I already cancelled before, I don't need to cancel again. It's already cancelled down. Now, if you'd have just went ahead and multiplied, 5 sevens are 35, and then 8 tens are 80, you'd have got 35 over 80. You then need to look for common factors that you can cancel down 35 and 80 by. You can do it that way, but I just think this way is better. So yeah, if you can get into the habit of cancelling before you multiply, I think you'll find overall that it's easier for you to do. Question 8a. A sequence is generated using the rule multiply the previous term by 3 and then subtract 1. Now the second term is in the sequence is 20. Find the third term in the sequence. Okay, so we've been given the second term, u2, that's equal to 20, and we want the third term, u3. Now we get the third term by taking the second term, u2, timesing it by 3, and then subtracting 1. So I know that u2 is 20, 3 lots of 20 is 60, take away 1, that is going to be 59. So the third term in my sequence is 59. Now what's the first term in my sequence? Well, u1, I'm going to get u2 by taking u1 and timesing it by 3 and then subtracting 1. Okay? So rearranging that, I'm going to get, so if I add 1 to both sides, I'm going to get 3 lots of u1 is equal to u2 plus 1. And then dividing both sides by 3, I'm going to get u1 is equal to u2 plus 1 over 3. Okay, so subbing in my value for u2, I know u2 is 20. So what I need to do is do 20 plus 1 over 3. So 20 plus 1 is 21 divided by 3. That is equal to 7. So that's my answer. u1 is equal to 7. Part B says, here is the first 4 terms of a different sequence, 5, 10, 15, 20. So find the nth term of the sequence. Well, this is quite an easy sequence, just going up in 5s, like the sequence 5n does. 5n is 5, 10, 15, 20, so that's just it. So un, the nth term, is just equal to 5n. Question 9. 80 students chose 2 activities, one from option 1 and one from option 2. Option 1 was football or hockey. Option 2 was athletics or multi-gym. This frequency tree shows the number of students choosing some of the activities. And part 1 says, or part A says, how many more students chose hockey and multi-gym rather than football and multi-gym? Well, hockey and multi-gym is this route through the frequency, isn't it? Hockey and then multi-gym. So that's going to be the answer there. It's those 14 people there. Rather than football and multi-gym, football and then multi-gym is this route through. And you can see that there are 12 there. So how many more chose the yellow route than the green route? Then that is going to be 14 subtract 12. That's equal to 2 then, isn't it? So 2 people, 2 more students chose hockey and multi-gym compared to football and multi-gym. Okay? Part B says 10 more students chose football rather than hockey. Complete the frequency tree. So that means 10 more people chose this one here than chose this one, didn't they? Okay, so if I've got 80 and then if it was half and half, it would be 40 and 40. So if I want football to be 10 more, if I take 5 away from hockey and give it to football, then hockey will go down by 5 and football will go up by 5. So that will give me 45 and 35 if you think about it. So I just halved the 80 first and got 40 and then subtracted 5 from one and gave it to the other one. And then the difference between them is going to be 10 then, isn't it? Okay. So if I've got 45 and 35 for hockey and football, I can now complete the rest. So if you think about this athletic one up here, So if I've got 45 altogether and then I've got 12 going to the multi-gym, that means the rest must have gone to pick athletics. So 45 subtract 12, that's going to be 33 then. So I'm going to have 33 students who chose athletics there. And then for the other route, I've got 35 people who chose hockey, and of those 35, 14 chose the multi-gym. So the remainder would have gone to athletics. So what's 35 subtract 14? That's going to be 21 then, isn't it? So that means there must have been 21 students who chose athletics there. Question 10, part A. The table shows charges made by a gas company to its customers. So in the table we've got the cost per day, which is 27 pence, plus the cost per unit of gas used, which was 8p a unit. So the owner of a flat receives a gas bill covering the period of 100 days. They have used 7,000 units of gas in that period. Show that their bill is for £587. Okay. Well, first off, we've got the number of days, which is 100, and the cost per day is 27 pence, isn't it? So I'm going to have to multiply these two together. So 27 pence times 100, that's 2,700 pence, which in pounds, I'd have to divide by 100 or put the decimal point there between the after the two zeros. So that's £27 then, isn't it? Okay. And then for the second part, we've got the cost of gas per unit is 8 pence, and we know we use 7,000 units of gas. So the cost of that then, if I times 8p by that 7,000, so what's 8 times 7? 8 times 7 is 56, plus I've got 3 extra zeros, haven't I? So 1, 2, 3. So I'm going to add those 3 extra zeros onto my 56. 1, 2, 3. So where does the decimal point go? So if that's in pence and I want pounds, then after coming 2 digits, that's going to be £560 and 0 pence, then, isn't it? So what is 560 plus 27? So that's going to be 785, £587 altogether. Okay, so that's the total. Part B says the owner of a house is supplied gas by a different gas company. The cost per day is 25 pence. They use 10,000 units of gas in 100 days. Their bill covering the period of 100 days is £975. Work out the cost per unit of gas used. Give your answer in pence. Okay. So again, we've got like 100 days. And the cost per day is 25p. So the standing charge, it's called, is going to be 100 lots of 25 pence then, isn't it? So what's that? And that's 2500. Again, I'm going to put the decimal point in there to make it pounds. So that's the standing charge. And then they're using 10,000 units of gas. So how much is that going to cost them? Well, the rest of the gas bill after the first £25, which is the standing charge, is the cost for all the gas then, isn't it? So if I take the £25 standing charge away from the total, it should leave me how much they spent on the actual gas then. So cost of gas, that's going to be equal to the £975 minus the £25 standing charge. Now that is 950 then, isn't it, when you take 25 away from 975. So the cost of the gas is £950. Now in pence, that is add another couple of zeros on, isn't it? So what I want to do is I want to make, so what's the cost per unit? Cost per unit. I'm just going to take that 950, add my 2 extra zeros to make it pence, and then I want to divide it by the amount of gas that got used, which was 10,000. So divide that by 10,000. Right, so I can do some cancelling out of some zeros to start with. So that one cancels with that cancels with that cancels with that. And I'm left with 95 divided by 10 then. So what's 95 divided by 10? That is going to be 9.5. So that's 9.5 pence then per unit. 9.5. Question 11. Triangle A is drawn on the grid below. Question A says, enlarge triangle A by a scale factor of 2 with the centre of enlargement at 0, 1. Okay, so marking the centre of enlargement, 0, 1 is the point here, isn't it? That's the centre. So then if I want to enlarge this shape, I need to count how far away each of the corners are of this shape and then multiply it by the scale factor. So if I take the bottom left corner of this triangle first, can you see it's 2 units away from the centre? So if I take that 2 units and I multiply it by 2, 2 times 2 is 4. So that means its image is going to be 4 units away from the centre of enlargement in the same direction. So I've already gone 2, so going another 2 takes me 4. So the image of that point is going to end up there. Okay? Now, there was already a corner there, wasn't there? There was the bottom right corner of my shape. Where's that one going to end up then? Well, that one is currently 4 units away. So if I double 4 away, it's going to be 8 away, isn't it? So I'm going to have to go another 4 then. So 5, 6, 7, 8. So the bottom right corner ends up there. And then I've got one more corner to find, haven't I? So then I've got this corner up here. Now to go from my center to that point, that's like 1, 2 along and 1, 2, 3 up. So then if I multiply that by 2, rather than going 2 along, I'm going to go 4 along. And rather than going 3 up, I'm going to go 1, 2, 3, 4, 5, 6 up. So that corner ends up there. Okay? So now we've kind of worked out where all our corners are. We can then join them up to make the shape. So my enlargement A will look like that. You know, if you look at it, you can see that it looks like the same shape, only bigger. So that's something to bear in mind. Yeah, and all the distances on my shape have been doubled. So if you look at the original one, it was 2 along the bottom, I've now got 4, and it was 3 up the side, I've now got 6. Now part B says, complete the description of the single transformation that maps triangle B back onto triangle A. Okay, well, they would have the same centre of enlargement, but they're going to have, rather than a scale factor of 2, which give you a shape which is twice as big, it's going to be a scale factor of a half. So it's going to be like a half with the same centre. So it's still going to be centred on 0, 1. Question 12. A spinner has 5 sides, numbered 1 to 5. If the spinner is fair, then the probability that it lands on the number 1 is 0.2, which is a fifth, isn't it? So a student spins the spinner 300 times. Assuming the spinner is fair, use the information to work out how many times the spinner is expected to land on the number 1. Okay. Now there's a formula for expected number of successes. And it's just equal to the number of trials times the relative frequency. Okay, so what is the number of trials? The number of trials we are told in the question is 300. So it's going to be 300 times the relative frequency, which we were given as 0.2. Now I'm going to rewrite that as a fraction. So it's just 1/5, isn't it? So what is 5s into 300? Well, 5s into 30 would go 6 times. And then I've got an extra 0 then, so that's 60. So I would expect there to be 60 successes in 300 trials if the spinner was fair. Now, the spinner actually lands on the number 1 on 58 of the 300 spins. Decide whether or not the results suggest the spinner is likely to be fair. Spinner, give your reason for your answer. Okay, well, 58 is pretty close to 60, isn't it? You know, you're always going to get a bit of variation, a bit of randomness when you carry out an experiment like this. So you're very unlikely to get the actual number of successes that you think. But 58 is only two ways, so I would be pretty satisfied that the spinner was fair. So I'm just going to say, decide whether or not the result suggests the spinner is likely to be fair. I'm going to say yes. It is likely to be fair because 58 is very close to our expected number of successes, 60. Question 13a, find the value of 2 to the power of 5. Well, 2 to the power of 5 is 2 times itself 5 times, so 2 times 2 times 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times another 2, that is going to be 32 then, isn't it? So that's equal to 32. The cube root of 1,000, well, what times itself 3 times is 1,000. It's handy just to know your cube numbers up to 10. I know that 10 times 10 times 10 is going to be 1,000, because 10 times 10 is 100, times another 10 is 1,000. So the cube root is 1,000 is 10. Okay, so just knowing your cubes up to 10 is very useful for the exam. And then I've got y to the power 12 divided by y to the power 4. When I've got numbers with the same base, like I have here, and I'm dividing, then I simply subtract the indices. So that's going to be the same thing as y to the power of 12 subtract 4. So just taking the indices away from each other, and 12 subtract 4 is 8. So that's going to give me y to the power of 8. So that's my answer, y to the power of 8. And then finally, I've got 5 to the power of p times 5, and that's equal to a fifth. Okay, so 5 to the power of p times 5. Now again, I've got two numbers with the same base. This time I'm multiplying them together, so that means I add the indices. Now that second 5 doesn't have an index showing, but if there's no index showing, then the index is always 1, because it's 5 to the power of 1. So 5 to the p times 5 to the 1, that is the same thing as 5 to the power of p plus 1, adding those two indices together. So the p plus the 1 is going to give you p plus 1. Okay, so the left hand, 5 to the p times 5, ends up as being 5 to the power of p plus 1. Now on the other side, I've got 1/5. Now 1/5 is the reciprocal of 5, and the reciprocal of a number is just that 5 to a negative index. So that's actually 5 to the power of minus 1. Okay, now if you see now, I've got two numbers with the same base which are equal to each other. So the indices here must be equal to each other as well, mustn't they? So if 5 to the power of p plus 1 is equal to 5 to the power of minus 1, then the p plus 1 part must be equal to the minus 1 part. So this part and this part here must be equal to each other. So that means I can write down that p plus 1, the index on the left-hand side, is equal to minus 1, which is the index on the right-hand side. And then I've got a little linear equation in p that I can solve. I can do that just by taking 1 away from both sides. So then p is going to be equal to, they're going to cancel. 1 take away 1 is just p. And then minus 1 take away another 1, that's minus 2 then, isn't it? So I'm going to get my p is equal to minus 2. That's my solution. Question 14. Rosa is thinking of a fraction. The numerator is a cube number less than 100. The denominator is a square number less than 100. The fraction is equivalent to 1 over 8. Find the fraction that Rosa is thinking of. Okay. Well, I think what I'm going to do is I'm just going to list all the cubes and squares that I know between 1 and 100. And I'm going to see which one I can find which is 8 times more than the other. Okay, so the cube numbers less than 100. Well, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and 5 cubed is already too big, isn't it? Because 5 times 5 times 5 is 125. So they're all the cubes that are less than 100. The squares that are less than 100, that's going to be 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, then we've got 16, 5 times 5 is 25. 6 times 6 is 36. 7 sevens are 49. 8 eights are 64. 9 nines are 81. And then after that, we're at 100, aren't we? Which is not less than 100. So my numerator has to be one of those numbers, and my denominator has to be one of those numbers. So I've got to come up with a fraction where my number on the top is one of these numbers, and my number on the bottom is one of these numbers there, and that the denominator is 8 times bigger than the numerator, so that it cancels down to 1 over 8. So can I find a number in the yellow list which is 8 times smaller than the number in the green list, or can I find a number in the green list which is 8 times bigger than the number in the yellow list? Well, I'm looking at U64, because 64 is 8 times 8, isn't it? So if I put the 8 from the yellow list on the top and the 64 from the green list on the bottom, then 8 times 8 is 64. So that should cancel down to 1 over 8 then, shouldn't it? So Rosa was thinking of 8 over 64 then. Question 15. The graph shows the time in minutes taken by some pupils to travel to school on Tuesday. So we've got less than 10, 10 to 30, more than 30, and a frequency there. Find the percentage of these pupils that took more than 30 minutes to travel to school. Okay, so we need to know, to work out the percentage, we need to know how many people there were altogether, and we need to know how many were more than 30. Now this is a very poorly drawn thing. I can't decide if it's a bar chart or a histogram. It's got frequency up the side, so which makes you think it's a bar chart, but bar charts are normally for discrete data, and they normally have gaps in between, so I don't know what this thing is. It's just a weird thing. Okay, so how many are there all together? Well, I've got 60 in the first bar. That has to just be frequency, doesn't it? I've got 150 in the middle bar, and I've got 90 in the end bar. So altogether, 150, 60, and 90. What does that add up to? 20. That's 300 students altogether. So there are 300 students, of which 90 took more than 30 minutes. So what we want to do is write 90 over 300 as a percentage. Now, a percentage just as a fraction over 100. So if I divide both of those numbers by 3, that's what I'll get, isn't it? So 90 divided by 3 is 30. 300 divided by 3 is 100. So that's 30 over 100, and that just means it's 30% then, doesn't it? Part B says, on Tuesday, the number of pupils taking the 10 to 30 minutes to travel to school was 25% less than Monday. Find the number of pupils taking the 10 to 30 minutes to travel to school on Monday. Right, so we know there are 150 students who went to school on Tuesday taking 10 to 30 minutes. And then if that's 25% less than Monday, that must be 75% of Monday's score then, mustn't it? Because if we had Monday's score and then reduced it by 25% and we've got Tuesday's score, then that is 75% of Monday's score. Now, if I divide that by 3, I should be able to find out how much 25% is. So 25% then is 50. So then if I want to have 100% of Monday's score, then I'm just going to add these two together, then, aren't I? So 75% and 25% is going to give me 100%. So 150 plus 50 is 200. So there must have been 200 students coming to school on Monday, so that when we reduced it by 25% on Tuesday, we're going to have 150, and that kind of makes sense, doesn't it? Question 16. An electrician charges £30 per visit plus £22 per hour. Write an expression for the cost in pounds charged by the electrician for one visit lasting n hours. Okay. So the cost then is going to be the £30 call out charge plus the number of hours times by 22 then, isn't it? So it's equal to 22n plus 30 then. Question 17. Annika has a shelf 79.6 centimeters long. She has many books, each of width 3.4 centimeters. Annika puts 2 paperweights, each of width 5 centimeters, and the maximum possible number of books on the shelf. Work out the amount of space on the shelf that is left over. You must show your working. Okay, so we've got these 2 paperweights, each of 5. So if I times them by 2, that means they're taking up 10 centimeters of the shelf then. So what's the remaining shelf? That's going to be 79.6 minus the 2 paperweights, which leaves me with 69.6. Okay, then we now need to see how many of these 3.4 centimeter books we can fit in that remaining shelf. So that's a division, isn't it? So the number of books is going to be 69.6 divided by the width of one book, which is 3.4. I think I'm going to do that as a division. Okay, I'm just going to make the maths a little bit easier by myself by multiplying both those numbers through by 10. So that's the same thing as 696 divided by 34. Okay, so I'm going to do a bit of long division. 34s into 696. 34 into 6 doesn't go, so 34 into 69. How many times does that go in? Well, 34 times table is 34, 68, 102. So you can see it goes in twice there, doesn't it? So it goes in twice. 2 lots of 34 is 68, and then subtract. That's going to be 16. 34 is into 16 goes 0 time. Now obviously there's going to be a bit of a remainder there, but I think it's a bit clearer, I think, if I work out how wide those 20 books are. So width of the books, that's going to be 20 lots of 3.4 then, which is 68 centimeters. Remember I had 69.6, so shelf remaining then is going to be 69.6 minus the 68. And that comes out to be 1.6 centimeters. Question 18. Jack has 10 cards numbered 11 to 20. He picks a card at random. Jack says, in these 10 cards, there are 2 multiples of 5 and 5 even numbers. Therefore, the probability that I pick a card that is a multiple of 5 or an even number is 2/10 plus 5/10 equals 7/10. Describe the error in Jack's method and give the correct answer. Okay, well, I guess he's thinking there are 2 multiples of 5. There are 15 and 20 as the multiples. And the even numbers are going to be 12, 14, 16, 18, 20. So his 2 plus his 5 makes 7 out of 10. But you'll notice you've got a 20 and a 20 here. So he's counted that 20 twice. Okay. Now you can only add probabilities together if they are mutually exclusive like this, and they're not, because they both contain a 20 and therefore they are not mutually exclusive. So I'm going to write down multiples of 5 and even numbers are not mutually exclusive, as 20 is in both. Okay, so the correct answer is, well, you've double counted the 20s, isn't it? So if I remove one, then you can see I've got actually 6 different outcomes that are one or the other. So it should be 6 out of 10, okay, and not 7 out of 10. If you're interested, the proper formula, the full formula for working out the probability of event A or the event B is equal to the probability of A plus the probability of B. like he's done, but you then need to take away the probability of A and B, the intersection of those two groups. And that's what we're doing here. But the fact that there is one number in both means I have to take 1 out of 10 away from 7 out of 10 in order to get 6 out of 10. Question 19. Felix makes craft figures at a constant rate. He can make 5 craft figures in 40 minutes. Find the number of craft figures that Felix can make in 4 hours. Okay. Well, if you can make 5 craft figures in 40 minutes, then time for one figure would be 40 minutes divided by 5, assuming he works at a constant rate. So he's just, churning out figures one after the other. And 40 divided by 5 is 8. So it takes him 8 minutes per figure. So then if I want to work out how many he can do in 4 hours, I'm going to have to divide 8 minutes into 4 hours. But units, I need to make sure 4 hours is in minutes first. So 4 hours equals 4 lots of 60. It's 240 minutes, isn't it? 240. Double and double again, times it by 4. So 240 minutes. So then what I want to do then is I want to divide my 8 minutes into my 240 minutes to see how many figures he can make altogether. So 8 into 240. 8 into 2 don't go. 8 into 24 go 3 times, remainder 0. 8 into 0 goes 0 times. It goes, he makes 30 figures. 30. Right, so then Darcy makes craft figures 10% quicker than Felix. Work out how long Darcy takes to make 15 craft figures. I don't really like the English of this. It's 10% quicker. What does that mean? I guess what it means is that Darcy's time is a reduction in 10%. So we have to take 10% off the time it would take Felix to make it, and then that's how much time Darcy would make them in. So if Felix can make 30 figures in 4 hours, then presumably Felix can make them in 2 hours, which is because it's half as much, isn't it? So 15s into 30 go twice, isn't it? So it's half the time. And 2 hours is 120 minutes, okay? So then Darcy is going to do that in 10% less time. If 100% is 120, then 10% would be 12 then, isn't it? So then to get 90%, I would need to subtract those from each other. So 120 take away 12, that's 108 minutes. So that's how long it takes Darcy to make those 15 figures. Question 20. Here is a question and an incorrect answer. Question. Expand the brackets and simplify fully. 3 lots of A plus 2B plus A. And he's written down the answer A4 plus 6 times B. Explain why the answer is not correct. Okay, well, it's kind of correct. It's just the way he's written it down is not quite right, is it? If I multiply this out, the brackets out, I'm going to get 3 lots of A, which is 3A, plus 3 lots of 2B, which is 6B, plus I've got this extra A on the end. So collecting like terms, the 3A and the A is going to give me 4A, and then I've got that 6B on the end, haven't I? Okay, just the same as before. Right, so it should be 4A plus 6B. Now, if you compare that with what he's written down, he's written A4, so he's got these the wrong way around. And rather than writing 6B, he's written 6 times B, so he's left the multiplication sign in. So that's the two things things he's done wrong. So it's not correct because the number and letter in the first term are the wrong way around. And he's left the multiplication sign in the second term. Okay, so that's what he's done wrong. He's made 2 mistakes. So So it's a 2-mark question. They're looking for both mistakes for the 2 marks, I think. So you need to mention both of them, I would say. Question 21a. Show that x plus 3 times x minus 5 is equal to x squared minus 2x minus 15. Okay. So when I've got 2 brackets, multiplied them together, the easiest way to do it is as a grid. So I'm just going to take the values from one bracket and write across here. So I'm going to get x and 3, and I'm going to write the numbers for my other down here, look, which is going to be x and minus 5. And then I just do it like a grid multiplication, just going to multiply like with like. So x times x, that's x squared. So x times 3, that's 3x. X times minus 5 is minus 5x. And minus 5 times 3 is minus 15. Okay? So what have I got there then? Well, I've got a term in x squared, which is here, look. I've got a term in... I've got 2 terms in x. So 3x take away minus 5x, well that's minus 2x. And I've got a term which is just a number, which is that one on the end there, look, x squared minus 2x minus 15. So that seems to work out. Now I think showing it in a grid like that is plenty enough evidence for this question, so I'm just going to leave it like that. Part B says the diagram shows a sketch of the graph y equals x plus 3, x minus 5. We need to complete the diagram by adding the values of the 3 intercepts with the axes. So we've got 3 intercepts. We've got 2 along the x-axis, here and here, and we've got 1 on the y-axis, which is here. Okay. Now, to find the one on the x-axis has the equation y is equal to 0. Okay, so the x-axis, if you think about it, is the line y is equal to 0, because y is equal to number of all horizontal lines passing through that value of y, and the x-axis passes through the y-axis at 0. Okay, so in other words, we want the values of x which are equal to where the equation is equal to 0. Okay, so if I've got 2 things multiplied together which give me 0, that means that one of the things must have been 0 to start with, or the other thing must have been 0 to start with. Okay, so I've got x plus 3 is equal to 0, or x minus 5 is equal to 0. Solving for x and just move that plus 3 to the other side. Take 3 away from both sides. I'm going to get x is equal to minus 3. And I've got adding 5 to both sides on this one. I'm going to get x is equal to 5. Okay, so they're going to be my 2 solutions that lie on the x-axis. This one must be minus 3, and this one must be 5. Okay, now the y-axis is when x is equal to 0. So what is the value of y when x is equal to 0? Now, if you remember, in the first part of the question, we started with showing that x plus 3 times x minus 5 is the same thing as x squared minus 2x minus 15, didn't we? Okay, so if I make x equal to 0, then x squared is going to be 0, 2x is going to be 0, and I'm going to be left with the minus 15. In other words, this number on the end here, this is the same as the y-intercept in the form y equals mx plus c or any other thing. So that thing there is going to be, like the constant on the end of your equation is going to be the y-intercept. It's going to be minus 15 down there. Okay, so they're my 3 intercepts. Minus 3 and 5 on the x-axis and minus 15 on the y-axis. Part C says the minimum point on the graph is marked T. Write down the coordinates of the point T. Okay, so we need the coordinates of that lowest point on the curve. Now, parabolas, they have a line of symmetry. So if there's a line of symmetry, then the distance from there to there must be the same as the distance from there to there, mustn't it? So my value for t must be halfway between minus 3 and 5. So what's halfway between minus 3 and 5? Well, if we add them together, minus 3 plus 5, and divide it by 2, then the x coordinate is going to be whatever that is. So minus 3 plus 5 is 2, divided by 2 is equal to 1. So that means t has an x coordinate of 1. So what's the y coordinate? Well, we can find the y-coordinate by subbing the x-coordinate into the equation of this line. Now remember, the equation of this line is y is equal to x squared minus 2x minus 15 in expanded form. So if I sub x is equal to 1 into this, I'm going to get 1 squared minus 2 lots of 1 minus 15. What's that then? So 1 squared is equal to 1, 2 lots of 1 is equal to 2, and then I've got minus 15 then. So I get 1 take away 2 take away 15. So 1 take away 2 is minus 1, take away another 15 is minus 16. Okay, so that means my coordinate t must be 1 minus 16. Looks about right, doesn't it? Because it's lower than the minus 15 on the y-axis there. Yeah, that looks fine. So that's 1 minus 16. Question 22. In this question, all lengths are in centimetres. Now we're told that the diagram shows an isosceles triangle ABC. AB is equal to AC. Find the perimeter of the triangle. You must show your work in. Okay. So we've been given the three sides of this triangle algebraically, but we have been told it's isosceles. And that means that this side here, AB, is equal to this side here, which is AC. Tells me here that AB is equal to AC. Now, it shows me here that AB and AC are those two values. Now, they look different, 5x plus 4 and 3x plus 7. But if they're equal to each other, they must be equal to each other, mustn't they? So that means that I can equate them. I can say, well, AB, 5x plus 4, must be equal to AC, which is equal to 3x plus 7. So what I've done here is I've formed a linear equation in x, which I can then go on to solve. Now notice I've got unknowns on both sides. I've got 5x and 3x. I'm going to take the smaller one away from both sides. So if I take 3x away from here, they'll cancel. But if I take 3x away from here, I'll be left with 2x on the left. So I'm going to get 2x plus 4 is equal to 7. Next step, I'm going to take that 4 away from that side. So they'll cancel, leave me with 2x. So I've got 2x is equal to 7, take away 4. That's 3, isn't it? So if 2x is equal to 3, then x is going to be 3 over 2, or 1.5 then, isn't it? It's 1.5. Okay? So what are the lengths of my sides then? So I've got 3 sides of this triangle. 2 are the same and 1 is different. So if I work out either AB or AC, I can just say the other one must be the same as that. So let AC look slightly easier. So the length AC then is going to be 3 lots of my value of x, which I found out to be 1.5, plus 7. So what's 3 lots of 1.5? 3 ones is 3, 3 halves is 1.5, so that's 4.5. So that's going to be 4.5 plus 7, which is equal to 11.5. Okay, so that means that side must be 11.5, but it also means that this side must be 11.5 as well, because they're the same, aren't they? It's an isosceles triangle. We do still need to work out BC though. BC is 4x take away 1. So that's going to be 4 lots of 1.5 take away 1. So what's 4 lots of 1.5? Well, 4 lots of 1 is 4. 4 lots of half is 2. 4 plus 2 is 6. So 4 lots of 1.5 is 6. Take away 1, that is 5. Okay, so BC is of length 5. So then my perimeter is going to be those 3 lengths added together. It's going to be AB, which is 11.5, plus AC, which is also 11.5, plus BC, which is 5. What's that all together then? Well, 11.5 and 11.5. 11 and 11 is 22, plus the 2 halves is 23, plus the 5, that makes 28. So that is my answer then, isn't it? The perimeter of the triangle must be equal to 28. Question 23. The diagram shows 2 right-angled triangles, ABC and BDC, and they're joined at BC. Okay, so we can see that line that they share is this one here. Work out the angle BCA. You must show your work in. BCA, where's that then? Oh, that's that marked angle there then, isn't it? This is the angle we're trying to find, this one down here. Okay, So how are we going to do that then? Well, I guess we can start in angle BCD, because I can see that's a right angle triangle where I know two of the sides, so I can use Pythagoras Theorem to find the third side, can't I? So let's start in triangle BCD. And so we've got a right angle triangle, so we can use Pythagoras Theorem. So BC squared is equal to 12 squared plus 5 squared. Now, I could square those, add them, and square root to find my answer, but I do know some Pythagorean triples that I memorized for exams that come in quite handy. One is 3, 4, 5, so 3 squared plus 4 squared is 5 squared. Now, the other one I know comes up a lot is 5, 12, 13. 5 squared plus 12 squared is 13 squared. Now, that's what we got here, isn't it? I've got like the 5 and the 12 along there, so the other side must be 13. So I already know that BC is going to be equal to 13. Now, if you want to try it yourself, you should, if you square it and add it, you should get 169, which is 13 squared. But just remembering your Pythagorean triples is very handy for these sorts of situations. So I know that BC is equal to 13. So let's just add that to the diagram. So then what we've got going on here then, so I've got another right angle triangle. So in triangle ABC this time, I've got a right angle triangle where I know two sides and I want an angle. So this looks like a job for trigonometry. So let's state the harmonic SOHCAHTOA and work out which ratio we're going to have to use here. Label out my sides. That 26, that's the hypotenuse, it's the longest side, isn't it? So I've got the hypotenuse. AB is the opposite, and BC, that's the adjacent. That's the side I just found. It's the adjacent to the angle. It joins on. So I don't have the opposite. I don't want the opposite. So I need to use the rule that's got to do with H and A. So I don't want the opposite. So anything with O in I can get rid of. So SOT has got an O in it. TO has got an O in it. So I'm left with the cosine. A and H. Look at that. So then writing out the cosine ratio, cos theta is equal to the adjacent over the hypotenuse, and then subbing in what I know. The adjacent is 13 and the hypotenuse is 26. So theta is the angle I'm trying to find, isn't it? So I'm just going to leave it in as cos theta is equal to 13 over 26 at the moment. Now that's equal to a half, okay? Now, if I had a calculator, I would now type into my calculator cos to the minus 1 of a half, or 13 over 26, and give me the answer. But I don't have a calculator because this is paper 2. So what am I going to do? Well, you should have remembered a whole bunch of angle sines, cosines, and tangents. Now, a handy way of remembering it is this little table. Sine, cos, big square root, 0, 30, 45, 60, 90. And then underneath the big square root, we've got the numbers 0, 1, 2, 3, and 4. And then we spin them around and we write 4, 3, 2, 1, and then 0, all over 2. Right, so this is like the handy shrink raid version of the numbers that we need to remember for the exact value. So we're looking for the number, the cosine that has a value of a half, okay? So we're looking for the cosine. So the cosine is these numbers along the bottom. Now, it needs to be over 2, which we've already got here. So what we're looking for is the 1 then. So scanning through this list, you can see my 1 is here then. So the cos of 1/2 I will get for this angle up here then. This is the angle I'm looking for. It's that 60-degree angle there. So the cosine of 60 is root 1 over 2, which is the same thing as a half. So the angle I'm looking for, theta, must be equal to that 60-degree angle there. Okay? So theta is equal to 60, and that's my answer, 60 degrees. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again.